Hey guys, what's up and welcome back. The next topic we're going to discuss is the preconditions and postconditions that we can use in the resources block to make sure that there are certain conditions that must be met before or after the execution of some of the Terraform operations out there. Let's discuss the concepts, and after that, of course, we'll just put those concepts into the execution. Terraform preconditions and postconditions are the custom conditions that are defined within your configuration to validate resources, data sources, and outputs when ensuring that it must meet specific requirements during the planning and applying phases. They are defined within the lifecycle blocks of resources, data sources, or outputs. Now you can include these things within the resources block, data sources block, or outputs block, but I would say generally they are put inside the resources block most of the times. Now there are two types of conditions that we can enforce: postconditions now and preconditions. Let's understand the postconditions and preconditions both one by one. Let's start with the preconditions. Preconditions are the conditions that are validated before the execution of the Terraform operations or before the applying phase or the plan phase. So the preconditions validate inputs and assumptions before Terraform attempts to create or update a resource, data source, or output. They ensure that the environment or the data provided is in a suitable state for the operation to proceed. They're evaluated before a closing block is provisioned. If the precondition fails, Terraform will halt the plan or apply process before the resource is even considered for creation or modification. So this means that the precondition block ensures that the condition that's included within the precondition must be met, and that condition must pass through even before the resource is being considered for the provisioning or modification. This means that if that condition fails, then the process to initiate the provisioning or modification of that resource will not at all start. The operation will halt itself. I would say the Terraform operation will be halted. The next thing is the postconditions. The postconditions are being checked after a resource is being provisioned successfully, and there's certain resource attributes that we're looking for example, the public IP address or the public DNS name of the instance. The postconditions verify that the resource, data source, or the output has the expected properties after the Terraform has applied the changes. They confirm that the provisioned infrastructure meets the desired state. Execution. They're evaluated after the enclosing block has been provisioned. If the postcondition fails, Terraform will halt the apply process after attempting the provisioning, indicating an issue with the resulting state. For example, you want to have the public IP address that's available after the instance has been launched. So the postcondition is the condition which is being validated or which is being checked after the resource is being provisioned. You have just initialized that resource, but before the completion of that resource's deployment, there are certain attributes that reflect for that instance or for that resource. For example, I've just launched an instance, and it takes few seconds for the instance to fetch the elastic IP address, the public IP address. So postcondition will check in that case that the instance that's been launched successfully, whether that instance retains a public IP address or not. If not, that postcondition will be considered as a failed condition, which means that condition will not pass through. In that case, the instance launching process will not be finished, the instance will be terminated, and that process would come to a halt. Let's go ahead and just try to put that into execution so that we can understand that in a much better way, because again, we can go endless and discuss these theoretical concepts, but we can put that into execution and see exactly that how they work or how these concepts are applied in a real world scenario. Let's go ahead and let's create a new folder out there. Let's make it as TF conditions. Let's keep it a simple name out there for this simple project. Of course, we have to just include main.tf config file. Let's copy and paste the Terraform and provider blocks into this thing. Let's right click, open the integrated terminal, and let's initialize this working directory by running the command terraform init so that we can install the necessary provider plugins. Now, we'll just go ahead and declare a variable first. So this variable that we are going to declare, let's save this thing, is for the instance type. So let's name it as instance size. Okay. and the type would be string. This is of the data type string, and the default value is t2.micro. Okay, so this is my default value for this variable that I've just declared. Now, just beneath this variable block, I'll just create a resource block, and let's name this as AWS_instance. This is the resource type, and the resource address, for example, I say condition tf ec2 or instance. I think let's make it as demo instance. So this is the resource address, the complete resource address, AWS_instance resource type, followed by the resource name. So this is my resource block that I've declared for the instance that we are going to launch. And the instance would be launched based on the condition checks, the precondition and the postcondition. Let's declare the AMI. Now I'll just pick the AMI from one of the config files that are already present in my folders. So let's copy and paste the AMI. And what about the instance type? So instance type, I just fetch the value from the variable instance_size, which is declared just above. What about the tags? Tags, I just include the name and as a key, and the value would be, for example, condition tf demo instance. Let's put that in the double quotations out there. The next thing is that we need to include these conditions, postconditions and preconditions under the lifecycle block. All right, once you just include lifecycle, then the first thing is that I just include precondition. Now, whether you include the preconditions or postcondition blocks, there are two main attributes that you must define. One is a condition, and the other one is the error message. All right. Then I also include a block for the post condition, and the same thing. It must have two main attributes, condition and error message. So inside this lifecycle block, the two blocks, precondition and postcondition. Precondition will check or validate the condition before the resource is being provisioned or modified, and postcondition will do after the resource is being provisioned. Now, in this condition, I want to say that var.instance_size should equal to or should be equal to either t2.micro, or it should be, so var.instance_size should be t3.micro. This means that these are the allowed instance type. If a user who's trying to use this config file to deploy the instance, if he or she deviates from these instance types, then the following error message would be displayed. Of course, the process to deploy the instance would be halted, and the following error message would be displayed. So you must choose either t2.micro or t3.micro instance type. So this is the error message will be displayed just in case if this condition fails. This condition will fail if the default value is anything apart from t2.micro or t3.micro. Then what about the post condition? Now the post condition is the one that's been checked after the resource has been provisioned. Now, in this case, the resource will be referred to as self. Self dot, now what's the attribute we're looking for after the instance has been launched? public_IP. So I'm saying that self.public_IP. By the way, self refers to this resource only in which this condition has been defined. So self.public_IP is not equal to null. So this means that this instance must have a public IP address attached to it after it's been launched. So the launched instance, this is the error message which will be displayed if this post condition is not met. The launched instance must have a public IP address attached to it or assigned to it. Let's go ahead and let's clear the clutter from the terminal. Let's clear everything out. Let's format everything using Terraform FMT. And let's run the validate command to make sure that everything is perfectly okay in terms of the syntax wise or logical structure is intact. Yeah, that's being done. So we have formatted the file, we have validated the file, everything is perfectly okay. Now let's try to make some tweaks over here. I'll just try to enforce the condition based on which this precondition will fail. How would I do that? I would choose a different instance size. I'll just go with the t3.small. So let's go with the t3.small. Okay. Now, once I do that, let's go ahead and run the command terraform apply auto proof. Now you will see that this will fail. This will lead to an error message. Let's see. Let's wait and watch. As you can see that this has eventually failed. Let's see this error. Resource precondition failed. So this instance size is t3.small. So this means that this t3.small value is not mentioned in this condition. So we have deviated from this condition. That's the reason this is the error it prompted, which we have typed under the error message. So let's go ahead and just make the correction. So let's make it as t3.micro, for example, t3.micro, so that this condition is being met. It does not fail. So let's go ahead and let's try to run this apply operation one more time. And you will see that this will be now a success. So Terraform apply auto approve, and you will see that this will be initiated without any error message because now we have corrected the instance size value. And as you can see that this is being initiated, and very soon this instance would be deployed. We can just cross check that, but it's just switching to the AWS Maven console. And if I just go to the EC2 dashboard, I will see that instance would be launched eventually. And yeah, here we go. So this instance has been launched and this is being initialized. So that's all about the preconditions and postconditions. Let's go ahead and destroy everything. So Terraform apply. Okay, one thing before I destroy everything, this self.public IP address is not equal to null is also being met. Because if I just cross check that on my AWS Maven console, let's go to the instance summary. This instance has a public IPv4 address attached to it. You can also cross check that if you just go ahead and go to the Terraform state file. You will see that once you just go to the Terraform state file, you will find out that we can find out. Let's do one thing, because there's a lot of data out there that we can just go through. Yeah, you can see that public underscore IP address. This is the one. So this post condition is also met. That's the reason this instance is now successfully running and it is almost launched. Let's go ahead and destroy everything. So Terraform apply destroy, and of course we have to just auto approve the changes so that we finally destroy everything. That's all about the preconditions and postconditions. Now these are the conditions that must be met before or after the execution of the Terraform operations, failing which an error message will be displayed on your terminal, and also the process will be halted. So that's it. Thank you so very much.